Good morning, ladies and gentlemen. The presentation I have the pleasure to deliver was prepared by the team from Gdańsk University of Technology that took part in the projects Roads and Live Roads, and most of the subjects were commissioned for the Safe Road project. I will briefly discuss the purpose of this research, the types of devices, the performance assessment, the results of the research, and we'll finish with conclusions and recommendations. In our presentation, in our paper, we looked in a greater detail at the ways of using energy-absorbing, a whole group of energy-absorbing devices. One example of such a device is a device that you can see in Polish roads, but also abroad. The device is called Safe End. It appeared in our roads a few years back, and there have been some concerns from the part of road managers, road manager administration, and they addressed the concerns to us, asking if it is okay to use them, are they safe, can we improve their visibility, and thirdly, what should be the design guidelines when barriers are fitted with the Safe End device. Continuing the introduction, the energy absorption devices that we discussed can be divided into three groups. One group is the crash cushions that you can see here in the picture. They're supposed to protect against a collision with an obstacle. And the concept of a crash cushion is basically a general term that's used for all devices that successfully went through 6 collision tests based on the Polish norm 1317, including head-on with a 1/4 slide, head-on at 15 degrees, sideways at 15 degrees, sideways at 165, and sideways combined. We have certain types of terminals which we describe as self-ending of protection barriers. Those terminals also have to successfully pass the crash tests. Same standard 1317. For these devices, there are only 6 ways of approaching. Impact of a heavy vehicle, that's 1.5 tons, or based on the 7th part of the standard, which is newer, more advanced and stricter. For both collision terminals of barriers and connections. Moreover, terminal connections which are tested under that standard can be tested in greater detail than traditional devices. So we can therefore describe them as innovative, which means that in some conditions they could be used as hybrids, as a collision cushion and as a collision terminal. That's why we have the third group, which is called hybrid energy absorption device. They combine the benefits of cushions and terminals. We've carried out field tests under the Live Roads projects that covers a considerable length of roads, and we found out that incidents involving a vehicle running into the edge of barriers, usually we have situations where either energy absorption device is hit or a guide rail device that reaches the ground. On average, we have approximately one on national roads, one such device per 100 kilometers. On expressways, we have 10 of those per 100 kilometers. This is probably because of the density of the junctions on those roads. Moving on to the actual subject of or object of the test, Safe End is normally used as beginning or ending edges of protective barriers. Whether it be the beginning of dividing belts or in exits from dual carriageways. When testing the device, we analyzed the reports from existing tests. These devices meet the requirements imposed by standard 1317, both as a crash cushion as well as a crash terminal, which means, well, for crash cushions, it's the third part of the standard, and for terminals, it's parts 4 and 7. On the whole, SafeEnd was tested in 8 out of 8 possible ways of impact, where the level of intensity, level of severity was in most cases ASIA. So to answer the first question that was posed in the beginning, SafeEnd can be used as a hybrid energy absorption device that meets the requirements for both collision terminal and a collision cushion. The answer for the second test meeting is also positive. It is possible to improve the visibility of the energy absorption device, and we don't talk here about SafeEnd only, but for all categories of SafeEnd energy absorption devices. We suggest changing the color scheme marking the front of the device. We can see here that the color schemes would depend on the location and the circumstances. The proposal, unfortunately, would require a change in the current regulations. Therefore, for the time being, it would be important to simply increase the area, the surface area of the front, and to add a fluorescent background without changing the color scheme. So there should be fluorescent edge beyond U9 device. We also run a bunch of simulations, a whole group of simulations on SafeEnd devices, in which we tested the behavior of the device, the behavior of the transition section, and the behavior of the protective barrier when sideways impact were delivered with vehicle. We used a number of variants, a number of options. We would change the impact angle from 10 to 35 and would vary the speed, impact speed from 50 to 110 kilometers. As a result, we could answer the third question that was initially imposed. There is a certain range of speeds in sideways impact which ensure the right rigidity of the device. Of course, provided that the ASI ratio is maintained at the recommended level, which means that, in fact, the device can adopt 4 times more kinetic energy than the normative tests require. So it's 4 times more than the minimum requirement, as you can see in the graph. The second answer to this question pertained to the most controversial part of this element, which was the connection or the link between the device and the barrier. What happens if the impact is place of impact is beyond the device? We found out that the radius of the connecting lane is essential because that determines the velocity and angle of impact. So this would probably call for some changes in the design requirements. But coming back to the graph on the left-hand side, we can clearly see that in a situation where vehicle impacts a protective barrier in connecting lanes, the threat of going through the barrier is less dangerous than other results of the impact. And at the end, we used the results of this research in order to attempt to assess the risk of collision of vehicles with the barrier, depending on the severity. We analyzed a number of scenarios. There was a connection between the device and the protective barrier on a connecting lane, and there were various parameters of the connecting lane. We can see that with a small radius, there is a considerable area of non-permissible threat, non-permissible risk. The situation very quickly improves the moment we increase the radius. And the best situation was on the right-hand side on the right, which is the recommended, where we recommend a long, low radius curve that's approximately 35-meter long before the actual connecting lane begins, so the actual curve of the connecting lane. So once again, between the beginning of the connecting lane and the edge of the device. Summing up, the results of the tests, both field tests and the simulations, confirm that the hybrid energy protection devices such as SafeEnd can be used in specified conditions. In justified cases, it is necessary to improve the visibility of the energy absorption devices by increasing the area and possibly in the future changing the color scheme at the front. Adopting the proposed geometry of connecting lanes, especially using a long transition curve of over 35 meters, could significantly improve the level of safety. And similar research should be carried out in the future for different types of cushions and energy absorption terminals, so that the new designs guidelines can be devised. Thank you very much for your attention.